Wireless sensor network (WSNs) often operate in low power and noisy environments where conventional modulation techniques suffer from noise interference, signal distortion, and synchronization problems. This limitation reduce communication reliability, particularly at low signal to noise ratios. Why this combination is important? This FM-CSK combination brings several improvements. Number 1. Lower bit error rate (BER). Fewer mistakes when receiving data. Number 2. Better performance at low SNR. Works well even when the signals are weak. Number 3. Stable synchronization. The transmitter and the receiver stay aligned. Number 4. Higher noise immunity. Reliable communication in a harsh environment. Wide frequency modulation (FM) and chaotic shift keying (CSK). Frequency modulation (FM) constant envelope property allows efficient power amplification and provides strong immunity to amplitude noise. Chaotic shift keying (CSK) enhance system security and improve resistance to interference. What is new about FM-CSK is that it combines frequency modulation with chaotic signals to make communication more stable, reliable, and practical for low-power wireless sensor networks. And this has been proven using real hardware experiments. Traditional frequency modulation systems are typically hardware-dependent, which limits flexibility and complicated system modulation. To overcome this issue, the study implements FM using a software-defined radio (SDR) platform, enabling software-based control and reconfiguration. A multi-mode FM system based on software-defined radio means that frequency modulation is done using software, not fixed electronic circuits. Because it is software-based, one SDR device can work in different ways. Multi-mode means the system can work in more than one mode. One mode can be software simulation, no real signals transmit. Another mode can be real transmission and reception using antennas. FM parameters, frequency deviation are changed using software. No need to rebuild or replace hardware when changes are needed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anastasia binti Muhammad Aziz S70250. My research journal is Analysis of FM Noise Parameter and Improving the Quality of Tune, Station and Alternate Frequency Strategy. Frequency modulation (FM) is an analog modulation technique that transmits information by varying the carrier frequency according to the message signal. Compared to amplitude modulation AM, FM provides better resistance to noise and interference, making it suitable for wireless communication system. However, FM performance can still be affected in low signal to noise ratio condition, where noise significantly degrade the quality of the received signal. Major challenges in FM system include high frequency noise dominating the demodulated signal, distortion and reduced audio quality, performance degradation when received signal power is low. This study analyzed the noise parameter affecting FM performance, focusing on the impact on frequency, deviation, and demodulated signal quality. To enhance system performance, noise reduction techniques such as filtering and optimization of receiver parameter are applied to suppress unwanted noise component. The result demonstrates improved signal clarity, increased SNR, and reduced distortion, leading to better overall FM communication quality. Next, principle and limitation of ultra-wideband FM communication system. Wideband FM, WBFM improved urban and traditional narrowband FM by using a wider bandwidth or larger frequency division. This allows it to deliver clear audio, reduce the effect of noise and interference, and maintain stable signal transmission even in challenging wireless environment. WBFM is therefore ideal for modern analog communication systems requiring quality and reliable signal. Example, better audio quality, ideal for FM radio and high fidelity broadcasting. Reduce noise and interference, suitable for urban wireless network. Stable transmission in multi-band environment, available for mobile or outdoor communication. Highest information capacity, can support multiple audio, channel or data alongside audio.
My name is Nurul Nadira Adilah binti Zulkifli. S70183, empirical mode decomposition (EMD) has emerged as a powerful technique for improving the performance of OFMD, that particularly in environment affected by multipath fading. The traditional methods such as simple channel equalization, adaptive modulation, or standard filtering techniques have been widely used to mitigate signal distortion and noise. However, these approaches often struggle to adapt dynamically to highly nonlinear and non-stationary channel conditions, limiting their effectiveness in real-world scenarios. EMD addresses this limitation by decomposing the receive of OFDM signal into intrinsic mode function (IMF), which allows for more precise extractions and signal features and isolation of noise components. By applying EMD, researchers have observed an enhanced signal-to-noise ratio (SNR), reduced bit error rates, and better resilience to multipath interference compared to older techniques. Moreover, EMD can be integrated with existing error correction and adaptive modulation SIM, providing a flexible and robust improvement safely strategy for modern OFDM systems. While older technology provide foundational tools for OFDM optimization, the introduction of EMD represents a significant advancement by enabling dynamic, adaptive, and fine-grained signal processing, ultimately leading to more reliable and efficient communication performance. For the new modulation technique called DCT and DST based frequency modulated OFDM, while in the traditional OFDM system, the discrete Fourier transform is used to modulate and demodulate the signals. While it has some limitation like sensitive to noise, interference, phase errors, and struggle in high mobility environments where the signal frequency changes quickly due to the Doppler effect. But to overcome this limitation, this paper proposed replacing DFT with DCT and DST, which is discrete cosine transform and discrete sine transform. So, to improve the DCT and DST error performance and noise handling, we use concentrating signals energy, which is DCT and DST, transform the signal into cosine and sine components. Most of the signal energy is concentrated in fewer coefficients, unlike DFT where energy is spread across many frequencies. When there's noise, it mostly affects the small coefficient. The main signal stays strong and fewer errors detected. While we can think like DFT is like scattering sand across a floor, and if the floor shakes, it's hard to find the original sense. So the DCT and DST pile most sand in one spot. Even if it shakes a bit, you can still collect. Signals survive and fewer errors.
My name is Tai Jiawen and my number matrix is S72078. Today I want talking about the performance evaluation of FM code moderation. So what we are studying about this is sending information using 0 and 1. Noise can disturb the signal. Noise causes error and the goal is reduce error. So what is the code? The code is using childish signal. Signals are irregular, which energy is not constant. So the problem with code is some bits are strong and some bits are weak. So the weak bits are affected by noise. So what is the FM code? Is code with frequency modulation, and each bit have the same energy and signal is more stable. So why FM code is better at low SNR is because the constant energy and easy to detect 0 and 1 and less affected by noise. So in this conclusion is code is simple but unstable, and the FM code is stable and affect flower error, and the third is better for noise environment. And in figure 1 is about the board diagram. So we can see the input data is inside the code modular. So the second is talking about the performance improvement of GFSK using common filtering technique. So what is talking about this is Bluetooth using GFSK to sending data, and noise and interference cause error. So the goal is improve signal quality. So what is the GFSK? Is Gaussian frequency shift timing. So using in Bluetooth and energy is constant, and the efficiency use of bandwidth. So the problem in Bluetooth receiver is using not coherent detection and symbol, and the low cost performance drop with noise interface runs from Wi-Fi. So they have three types of the common filter. The first is KF, the second is EKF, the third is UKF. So what is the help from common filter? Is estimate signal error and the reduce noise effect and the improve detection accuracy. So the performance result is BER is reduced and the FER is reduced, and the all common filter output from the signal without the filtering.
Recent research introduced integrate sensing and communication using FMCW waveform, where radar sensing and data transmission operate simultaneously on the same signal. New design combine FM and chip-based frequency, hoping to improve interference resistance, security, and spectral efficiency, especially in low SNR environment. These advances make FMCW-based system highly suitable for automotive radar, sensor network, and future 6G wireless. Study shows that FM demodulation remains highly robust under adaptive and multi-captive noise, even at low carrier-to-noise ratio. Modern digital FM demodulators and adaptive noise suppression technique further enhance signal stability and detection reliability. This confirms that FM-based system provides strong noise immunity, stable synchronization, and reliable performance in noisy wireless environments.